Dear student, today topic is about VSEPR theory. Full form is V valence, S shell, E electron, P pair, R repulsion. Valence shell electron pair repulsion theory. Okay, what happens actually when two atoms they come close to each other to form a molecule, then both the atom has their valence shell and their electrons, I mean the electrons present in the valence shell, those electrons they repel each other. Okay. So, what happens in chemical bonding? The groups who are going to form bond with each other, okay, they arrange themselves in such a way so that the repulsion force should minimize. VSEPR theory is very helpful in bonding of molecules. Let us see the postulates of VSEPR theory now. This theory is used to predict the shape of the molecule. Suppose what happened that this hand posture is like this, and suddenly what happened, one snake came suppose, and I am watching that, oh, snake came. So, suddenly I saw that snake came and I just pulled my hand here like this. So, what I did, I changed my posture, I changed my position just to protect myself from the snake. Same thing, what happens in the molecule, their atoms they feel repulsion due to their bonded electrons or sometime lone pair electrons, okay, they feel repulsion. So, what happened, one snake came, my shape has changed, now I am okay because snake will pass from here, it is okay, alright. So, this is my stable shape, this is not my stable shape due to that snake, this is my stable shape. In same way, to minimize the repulsion, the finalized shape, how it looks like about any molecule, VSEPR theory is helpful to predict that, okay. Alright. So, let us see the second postulate of VSEPR theory. Who introduced this? The theory was first presented by the Sidgwick and Powell in 1940. The next postulate about VSEPR theory is it is used on the basis of assumption that the molecule will take this type of shape due to that type of repulsion, due to that type of attraction, like that. This is assumption actually, okay. See, wait, what happens? Suppose any person who is my enemy, okay, he is firing bullet with the gun okay, and he is standing in front of me. What will I do? To protect myself, what I can do is I can shift myself bit down, or I can shift myself bit right or bit left, so that the bullet what he is firing can pass without touching me. And the bullet was coming from this direction, I shifted myself here, bullet passed. So, this is my final stage, stable state now, okay. So, VSEPR theory is overall tells about the final structure, final geometry of the molecule. Let us see some other points about VSEPR theory now. The next postulates are like the shape of the molecule, okay, any molecule, its shape depends on the number of valence shell electron pair, that how many electrons that atom has in its valence shell, that will decide the shape of the or geometry of the molecule. And electron pairs occupy position, okay, such as to minimize the repulsion. What happens? Suppose any fire, okay, is coming towards me. So, of course, fire will burn my body, yes or no? So, what will I do? I can wear something like thermal coat so that I can protect myself from fire, okay, or I can just myself shift somewhere from not in this room, some other room, so that I can protect myself fire. So, again and again with each and every point, what I am trying to say you is VSEPR theory explains the shape of the geometry of any molecule where the molecule is stable with the least repulsion, getting or not. This is what I am trying to say in the VSEPR theory. Let us see some other facts about VSEPR theory. What happens? Repulsions are between bond pair, lone pair. What these are? See, suppose I am writing here oxygen, hydrogen, hydrogen. Okay. This is bond. So, these electrons are like bond pair electrons. See, one electron here, one electron here, one electron here, one electron here, right? These are the bond pairs, and here is lone pair. Lone pair means those electron pair who are not participating in the bond formation, correct? So, what happens? Here is two lone pair. This lone pair is repelling this lone pair. Okay. So, this is called lone pair repulsion, LP repulsion. Okay. Next, this is lone pair and this is bond pair, correct? So, this is called lone pair bond pair, LP repulsion. Okay. Next, this is bond pair, this is also bond pair. So, we will say this is bond pair repulsion, BP repulsion. What I wrote here is LP, then LP, then BP. You got it? LP, BP, LP. I hope you got the full form and all, right? Okay. What happens? Question comes. They ask the question that where is the maximum repulsion between LP or LP or BP. So, let me tell you, maximum repulsion is at the LP. Then little bit less repulsion is at the LP, and BP has least repulsion, correct? Okay, wait. That is why I wrote the point here, LP greater than LP greater than BP repulsion, correct? Now, understand the logic here. If they repel each other at maximum level, then more angle will form. Suppose this is the situation, but due to repulsion their angle will increase, yes or no? They will go far from each other, their angle is increasing with time, correct? Here is maximum repulsion, so maximum angle formation will be here, correct? Here is bit less repulsion, so less angle formation. Here is least repulsion, so less angle, correct? Okay. This is suppose theta 1, this is theta 2, this is theta 3. So, the bond angle is, where is the maximum repulsion? Between lone pair. So, maximum angle also. So, theta 1 greater than theta 2 greater than theta 3, correct? So, same thing I wrote here, the repulsive forces decrease as the distance between bonded atom increases, therefore, bond angle increases. Okay. So, what I am trying to say here is that if repulsion is more, bond angle is more. Okay. Bond angle increases, see the last word, bond angle increases, correct. So, this is what I tried to say here. So, now we should see one chart, okay, where VSEPR theory is explained with some structures. Let us see the chart now. So, in this chart what I am trying to say is number of electron pairs 2, okay. Number of electron pairs 2 means what? 2 pair, 1 pair contains 2 electron. So, 2 pair contains 4 electron. I hope you got the idea. So, number of electron pairs 2, you can see the first column, okay. Then after that AB2 molecule, how you see? See, 2 pair means 4 electron, no doubt, okay. Now, there is a molecule, can you see AB2 there, okay. So, in AB2, A, B and B, correct. How many pairs? 2 pairs. So, 1 pair and 1 pair, 2 pair, correct. Okay. So, this is AB2 format, okay. This is a straight line, yes or no? Straight line. So, we can call it linear shape. What conclusion I got? And okay, linear means what? What is the angle? 180 degree, right? Examples are like BCl2 molecule, HgCl2 molecule, CO2 molecule, CS2, HCN, BF2. So, these are the molecules where you can get the linear shape. These are the examples in the last row, okay. And their molecular geometry looks like linear 180 degree, okay. So, molecular geometry also I explained, shape also I explained, right. Then there is a AB2 format. So, AB2 format I told you like BCl2, BF2, CS2, CO2 like that, okay. And number of electron pairs are 2. So, here is 1 pair and here is 1 pair, 2 electron pair. I hope you got this chart. In same way we expand after 4 also. but in the class 11th. Till here we have only 4, till 4, okay, like 2, 3, 4 like that. Okay. So, I hope you got this chart, that how it explains the geometry, shape and number of electron pairs and their example. So, you have completed the VSEPR theory postulates and this chart. Thank you for watching.